Okay, we're continuing our lecture in supervised learning, and now we're talking about some of the information that would be helpful for us as we're trying to assess the classification error, the classification accuracy. And so a simple prediction of the test set has 4 possible outcomes. And so we're going to be considering those here as we work through this material. And so we have the true positive TP, true negative Tn, a false positive Fp, and a false negative Fn. And so those are all listed here in this table. So TP and Tn are the correct classifications, and then we have 2 incorrect. So a false positive and a false negative are the ones that we're trying to minimize as much as possible. And so thus we get this confusion matrix that we have listed here, shown in this table. The miscalculation classification rate is Fp plus Fn. So the false positives divided by all 4 of the values, Tp, Tn, Fp, and Fn. And the true positive rate is approximately equal to the positive correct classified to the total positives, and that is equal to Tp divided by Tp plus Fn. So this determines the sensitivity of the detection for abnormal events. A classification method with high sensitivity would rarely miss in an abnormal event. Fp is equal to Fn. The false results are equal to 0 is the desired outcome that we want to be striving for. For the true negative rate, and so the Tn rate is approximately equal to the negatively correctly classified divided by the total negatives, which is Tn divided by Tn plus Fp. And the true negative rate determines the rate of detection of the abnormal event. High specificity results in low false alarm rates when the classification of a normal event is selected as an abnormal one. And here we just have some of the math that we can be laying out for this, and both high sensitivity and high specificity are desired. All right, we'll just finish up with this last 2 charts. We'll talk about the rate of change curves, ROC curves. When a classifier algorithm is applied to a test set, it yields a confusion matrix. And so we just talked about that confusion matrix. And it corresponds to 1 ROC point. An ROC curve is created by the thresholding the classifier to levels of complexity. Each level of complexity in the space of a hypothesis class produces a different point in the ROC space. Comparison of 2 learning schemes is done by analyzing ROC curves in the same ROC space for the learning schemes. So that's the general thoughts here. And here is an example of what a sample ROC curve would look like. And so you can go ahead and review these charts, or go back and pause the video and see how this would relate. But we'll definitely see how this rate of change goes over time. You can see that we come to a flat spot here. So we're not getting any more rate of change. And so that can be a useful bit of information for us to capture. All right, well, that's it for our second lecture in module 2. And thank you very much.